Awesome. So to kick off this Git and GitHub workshop, a few housekeeping items is that if there are questions, please use the chat in Zoom. And then also, if you just want to speak up, feel free to unmute yourself and ask questions or chime in. This is more of an interactive workshop, less so of me speaking at a screen. So feel free to bring that interactive piece if you'd like. I'll also share the content links in the chat. So I'm pasting a link right now, and this is what we'll be going through together. But yeah, so by the end of this workshop, the goal is that you'll understand what version control and Git are. You'll also know how to use Git and GitHub to store your work and collaborate on code with others. So those are our two main goals for tonight. This is separated into two parts of the workshop. The first being the link I just shared, which is more around concepts and theories. So what is Git? What is GitHub? And then we'll go into a more hands-on section where we'll be working through some scenarios together on how to use Git and GitHub. So that's where you'll need to have a GitHub account set up and also to have Git installed and Git bash installed on your devices. So if you don't have that set up yet, no worries. We can go and kind of go through that during the break. So there'll be a break in between the two sections. Awesome. Any questions before we start? Perfect. So I'll share a screen. And Jasmine, can you give me the thumbs up if you see it? Perfect. So first of all, if you are familiar with Git and you're here for a refresher, there might be some resources that are useful to you. And also you might find these useful by the end of this workshop if you continue to use Git beyond tonight. The first is a Git cheat sheet. We all love cheat sheets. And the second is a scenario-based website where it'll show you if something went terribly wrong and you need to revert something, what do you do? So I find these resources quite useful. There are two versions of it, but they essentially contain the same thing. So here are some useful resources that you might want to come back to. And now we'll get right into it. So the first is, we want to know what is version control? What is all this about? And version control is a platform to track changes, share code, and to work on the same file. Now, there are many different types of version control, an example being Google Docs that you might all be familiar with. If we make a Word document on Google Docs and share the link, then people can collaborate on it, write on it at the same time, or I can just use it for myself and track the history of my changes. So an example being here, where I've made changes at different points in time, and then other people have also made changes. And you can see that in the past, I've deleted this line. So the main use of this, if I'm using this for myself, is that I can go back in time and recover something that I've deleted or changed if I didn't like my current version. And also if on a collaboration kind of standpoint, we can work on the same document at the same time and kind of not overwrite each other's changes in that way. So we can think of version control like Google Docs in terms of collaborating and also tracking changes in history. Now, Git is another example of version control, much like Google Docs. And it's mostly used for storing code and also code collaboration. So where you would use a Word doc in Google Docs, we use code like R scripts, Python scripts, etc. In Git. So for Git, there's a concept of storage locations. And this is kind of key to understanding what Git is. So there are two storage locations. One is local and one is remote. Files are first stored in your local when you create them. So local is like your physical computer. If I save a file, any type of file, it will be in my local right now. If I save it on my desktop, that will be local. And then remote is the second location, where it is essentially the cloud. It is essentially Google Docs in our previous example. And we'll go through this diagram together to further illustrate what Git is. So this is a collaboration scenario where there are two users who want to work on the same piece of code. Now, if I just save the piece of code on my computer, nobody else will be able to see it. We can't work together on it. But if I upload it to the remote repository or the cloud, then I can go and share that piece of code or that file with someone else. For example, I send it to Jasmine. Now she can clone it, or she can basically tap into the cloud and access this file that I've shared with her. And now we can both work on that piece of code or that file together, much like a Google Doc. So note that if I don't upload that file into the cloud, Jasmine won't be able to see it, or the other user won't be able to see it. And likewise for the other user's files. So there needs to be an act of uploading the file to the cloud for it to be shared. Any questions so far? Okay. So there's a list of Git terminology, which I won't get too much into because we'll cover it naturally through the examples, but it's more of a reference for the future. If you're confused about what do I mean when I say PR, there's a quick explanation right here, or you can pop the question in the chat. So now that we know what version control and Git is, we'll answer the question of what is GitHub. So GitHub is that cloud piece or that remote piece of Git, where it's a platform where it stores code and files. We upload things to it. It's basically the Google Docs of the coding world. So there are also a lot of features that make collaboration easier, where we can compare files if two people make changes to see what version to keep or what pieces of each version to keep. We can file issues, almost like filing an IT ticket per se, and have conversations logged in a project. So GitHub is basically a platform which we will be interacting with in the second half of the workshop. And just a fun fact about GitHub, this is the logo that you'll probably see. It's actually an octopus cat, and it represents how complex code combines can be to create peculiar things. So it's kind of, it's encouraging that combination or collaboration of code. But yeah, that's essentially what GitHub is. It's the cloud or the remote piece of what Git is. Now we'll get into more tangible examples of how they're used. So I mentioned that it can be used to track changes, and this is commonly used by a single user. So imagine if I'm working on a project by myself, and I make some code changes, and then I save it, and I want to keep all the backups. This is maybe what it would look like. If you're familiar with this naming format, there's my file, and then there's version 1, version 2, and then what I thought was the final, and then what I thought was the actual final, and then the real final. So this is one way to track changes. And it might be effective for some more simple projects or some kind of quick projects. But what if I want to come back to it in a few months, or I want to share this with people? Not as easily, this format is not as easily shared because I'd have to send all these files to people and they would have to read it through, see what the changes are. So I would use Git to kind of save all these changes, and it would be one file. And I can go and look at the history of it. We'll see an example of it in the next section. So it's really to be used for tracking changes, backing up files. And if I ever want to go back to a version, I can just easily do that through Git. It's also a place where we can store Readme files and just have a nice format for a project. And it can be used as almost a portfolio too. So if you're looking for, if you're job hunting or just want to share some of your projects, Git is a good platform because you can just send a link to your profile or to your project and people can see your work. On a collaboration standpoint, there are a lot of benefits to using Git and GitHub when working together on coding projects. So like I mentioned before, if I wanted to work on a project, let's say with Jasmine, and we're modifying the same file. In this example, where I save things in my folder, I would have to work on something, either email it to Jasmine, send it to her, and then she would have to work on it, send it back to me, and there would be a lot of back and forth and just file transferring in that sense, which may be inefficient if we both want to work on it at the same time. With Git, it solves that problem because now we're both accessing the same file in the cloud and kind of pulling it into our local environments or downloading it to our local environments and then pushing it back up or uploading it back up to the cloud. You can also manage permissions. So if you just want to share your work but not allow people to modify it or to write, you can do that and set permissions. There's also a code review process. So if you're working on something that will go into production, you probably want to go and test it, have someone review it, and there are mechanisms to facilitate that review process. You can also make copies of a project. So if Jasmine has a really cool project that she's working on, and I want to try making my own version of it off of her code, I can actually kind of copy her project and then make my own changes without affecting whatever Jasmine is working on. So here's a more tangible example of what branching or this kind of copying is. So if we take these circles as points where we save a file, this is our main branch, where our main branch is essentially our project, our kind of main version of our project. And then, so it's created, and then a change is made. Now, at this point in time, I want to start doing something else that may or may not work. I want to test it out first, and I don't want to affect the main project. This is where I would create a branch. So I would essentially copy this project, make some changes, and then thankfully it worked. So I would merge it back or kind of copy or combine the changes back to the main branch. And this is useful because at the same time of me trying to test these new changes, Jasmine comes in and she also wants to make some changes. She's able to do that without affecting my work and without my work affecting hers, because she creates another copy right here in the green path. And so eventually, if her changes work out and she likes them, she can also merge or combine her changes back into the main project. And an example of this will be something here, a project that I've worked on, where you can see that the tree diagram on the left is kind of a rotated version of what I have here, where let's say here, this purple line here on the left is that main branch. So that's our working version of an application. Now I wanted to work on user timeline API feature, but I wasn't sure if it would work. And I didn't want to make changes directly on that working project or that working app. So I created a copy, made my changes. Great, it worked. Now I merged it back, or I combined the changes back. And now there is this user timeline API feature on the working app. At the same time, one of my partners wanted to change the logo and add better UX to the pages. And he went and did that. But then our changes don't overlap because we created separate copies. And once we tested things out, we were happy with what we wanted to do. That's when we combined our changes back to that main app or that main version of the project. You can think of these branches almost like a development or like a scrapbook on the side, where you try to make changes, you test things out, you might fail. It might look ugly, but then at the end, once you have tested or not so ugly product, you can merge it back or combine it back to the main project and show the world on your GitHub page. So any questions with that example or with anything we've just talked about? Awesome. So with that, that caps off the theoretical or the conceptual part of the workshop. We will go into the hands-on portion. But before we go into the hands-on portion, I did want to share a comic that I really enjoy about Git that some of you may or may not have seen. So this reads, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. So the one right here. The next person says, cool, how do we use it? And they respond, no idea. Just memorize all these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and just download a fresh copy. So all that to say, Git is actually quite complex. We're only touching the surface today. And it's okay to be confused. It's okay to not quite understand what is happening, why are we typing these commands, but that's where we ask questions. And that's why I'm not just sending out this workshop and the website for you to follow along yourself. So this is your chance to ask questions if anything is confusing, but don't be afraid if things get confusing in the future too, once you use GitHub more often and Git. Jasmine just proved our point where she mentioned she just did delete and download a fresh copy today. So that's almost like a reset. If we screw things up, we don't like what's happening, we don't know what's happening, just delete everything and download a fresh copy. But do note that changes will be lost in that way. Okay, so Jasmine, are you able to share the poll results with me?
Yes. Do you want me to just share my screen and everybody look at it together, or oh wait, I think I can copy the link to it and you can share it from your screen.
Sure, that would work.
Let's see if this works. I'll paste it in the chat. I think that's the first one.
Oh, maybe you're the one who has access to it.
Oh, it doesn't show it?
No.
Okay, wait.
Oh, if you vote on one, it will show you the results.
Oh, okay, sure. I'll vote on one.
Thanks, Yuka.
Thank you.
Cool. And let me just share the other results too. Okay, I sent the second link.
All right, perfect. So in this workshop, we'll focus on the RStudio version of using Git and GitHub. The instructions on this, this website are more geared towards Git Bash, which is the command line version. And it still works if you use RStudio. It just might be a bit more complex. But if you also use other languages like Python, Java, etc., this might be more applicable for you, the Git Bash version or the command line version. But for this workshop, we'll focus on using RStudio and using Git through RStudio. Okay, so at this point in time, does anyone have any challenges installing Git or installing or setting up GitHub? If so, please ask in the chat. And if you don't have it set up, that's okay. Feel free to just follow along on the screen also. But we'll get right into it if there are no other questions. So first we'll open up GitHub and log in. And you'll see a screen much like this one. And so the next step is we'll click. So what we're doing is we're going to create our first repository in GitHub, or a new repository in GitHub. The repository is almost like a folder for all of your files or other folders in a project. So it kind of contains a project. So to do this, we will click on this new button on the top left. You'll see your ID right here. And then you can name your project or your repository. So I'll name mine my first repo. You can add an optional description. I usually do that because I have a terrible memory. And if I come back to this in a few weeks, a few months, I will probably have very little idea of what's happening. So in the description, I'll write something useful that future Shannon will probably understand, hopefully. And that'll be, so this repo is for a Git and GitHub workshop demo. Now, if you want this to be shareable with the world, you can keep it at public. If you're doing something that you don't want to share yet, or you don't want to share ever, put it on private. So I'll leave mine on public. And there are more options here. I usually do add a README file, and that's essentially a longer document of kind of what is your repo about. So I usually click this. Don't worry about the other two just yet. That might be, you might be using them in the future once you're more familiar with Git. So once these settings are done, so I have my repository name, an optional description, check the security settings. I may or may not add a README file. It's really up to you. You can hit create. And yes, good note, Jasmine, is that repo is short for repository. So I'm lazy, I'll say repo, but it's really the same thing. So you'll see here, I have a README file because I've selected that option. And this is our first repository. I'll stop here for a few seconds. Any questions, feel free to put it in the chat.
And I don't know if you're going to talk about this later, but do you want to just quickly talk about the main branch that you see at the top left there? And you might see some other repositories with something else.
Yeah. Are you talking about main and master?
Yeah.
Okay. Yeah. So this main branch is kind of that default branch or default version of your repository. You might see master in that same, with the same definition. So instead of main, it might say master in some projects. And that was the old naming convention for main. Before, I want to say it's been a year or 2 years, around there. 1 or 2 years ago, it changed to main instead of master. But some of the older repositories that weren't updated will still say main, will still say master. So the old version is master, new version is main. They essentially mean the same thing for our purposes. Yuka, did you have a note?
Yeah, I just wanted to chime in to just kind of give context as to why this change has happened. So there's a lot of lingo in computer science that's very inappropriate. So master was one of them, and and there are other languages, like there's the master, and then whatever is below the master would be called slave, which is so awful. So this is a movement within like the computer science world, and also with like programmers to try to move away from that very, racist terminology. So that's one of the reasons why GitHub has shifted away from master to using main.
Thanks for that context, Yuka. So yeah, that's the note about main and master branches. For our purposes, we can understand it as the same thing. Now we talk about a README file, and it's quite simple right here. It doesn't really tell us much. It only has the description, but I want to show you an example of how a README file can be used. It's kind of like your title slide or your introduction to the project, what you want people to see when they first come in. So in another project that I've worked on, a Pokemon classifier, you can add details about what you're doing. So this is a binary classification model for identifying legendary Pokemons. You can add hyperlinks to different versions, different sections of the project. And so if you want people to go to the methodology section, which is to be decided, you can add a hyperlink there. So yeah, this is one use of a README file. You can add pictures. It's basically a document. It's documentation for your project. So you can also update this to look something more like the example that I shared, if you'd like. So if we don't have any questions about creating a repository, we'll move to cloning it. If we go back to the diagram here, I pull it back up, you'll recall that there was a local environment and a remote environment. So right now we have this project or this repository in the remote environment. It doesn't quite exist on my computer yet, and I need to clone it or download it onto my computer. And that's what we'll be doing next. So to clone a repository, what I'm going to do is I'll need to open up R Studio. So everyone can do that. And hopefully their R Studio is a bit cleaner than mine with fewer untitled documents. Next, we're going to go back into GitHub and click this green button on the repository. And then copy this URL. So hit this button and copy it. Next, at the top right of RStudio, click this dropdown, and we can select New Project. After selecting that, we'll click Version Control because we want to use version control, which is, or Git is an example of version control. So we'll click that, and we're going to use Git today. and paste the repo URL that we just copied from here into this section right here. And it'll automatically populate the directory name. If for whatever reason you want to have a different name on your local, so on your computer, you can change it. But it does get a bit confusing, at least for me. So I usually keep it the same between my local and my remote. And then you'll also decide where to store this. And to give you context, how I like to function is that I have a folder on my computer called Workspace, and I have all my repos cloned here. You might have a different file structure depending on what kind of projects you're working on or who you're working with. But I like to put all my repos in one place so I know where they are. So I've navigated to my Workspace folder. You can hit browse and go through all that. And because I want it here, I'll click create project. You'll see that it's now a folder right here. And so you've now successfully cloned your repo to your local environment, or essentially downloaded a copy of your repo to your computer. You'll see that the project up here will say the repo name, and that's when you know you're in that project or you're in that repo. So any questions about cloning a repository? And for those of you who may or may not be interested in using command line or git bash, there are instructions on how to use it here. And if we have time at the end and people are interested, we can also go through those commands. But we've gone through all these steps of how to make your first repo and then clone it or download it onto your computer. So now it's time to make your first commit. And what that means is we're going to upload something or save something to this repository. Now, this is the part that I was initially confused about when I was learning Git, and I don't know if it'll be confusing for all of you, but I found that this diagram does help. And we'll work through an example here where we can all create a new R script. So right now I'm trying to add a file to the repository. So create a new file. I'll pretend that there's some code here, save it. And you'll note that it saves right into the local repository. So you can call it anything you want and just save it in there. And you'll see that this demo script is saved right into the repository here. So you can go ahead and do that. Create any file. It doesn't have to be an R script. It can be a text file, anything. So once you've done that, we're going to go through git add and git commit. So you'll want to hit the git tab right at the top right here. So click that. And you'll see that there are some files and some question marks up here. If you hover over the question marks, it'll tell you what they mean. This means untracked. So basically, Git isn't looking at it or tracking it yet. It's not tracking any changes yet. So it's the same as any other file right now. If I want to track changes or track the change history of a file, I will have to tell Git, because by default, it won't look at everything in your computer and kind of track the changes. So because I want to eventually upload the script into GitHub, I'm going to click this check mark and stage it. This is telling Git that, yes, I want to save the changes for this file. And that's the action of git add. If I wanted to change or to save more files, I can also git add them. For now, I only want to add my script. So we've just done this, this phase of git adding by clicking this check mark. Essentially, it's telling Git, please pay attention to this file. I want to track the history of my changes for this specific file. Next, we will go to git commit. So we'll click this commit button, which will bring us to a new window. And you'll see that this is in green. So it's telling me that, oh, Shannon has added this line into the file. So this is what's new. Now I need to type a commit message before I can commit or actually save these changes. These commit messages will help me in the future when I come back and want to see what changes did I actually make. This is quite simple because it's only one line of code. But imagine if you were working on, let's say, an application and you've created a whole section of, let's say you've created a whole page of a Shiny app and you've written some code here. You will want to document that and say that, let's say, created a page in app. So that in the future, when we look at, for example, this view, I kind of know what, more or less what happened. Let's say we removed a CSV from the git ignore list, or we fixed a bug. Usually we would want to be a bit more descriptive than that, so that if we just look at the message, we don't have to go through the entire piece of code to see what happened. So that's the purpose of a commit message, to describe what happened. And a successful commit message is one where you can just read it. You won't have to go through the code to see what happened. So this is the action of almost like saving your changes. Once you're happy with your message, you can click commit and it'll tell you, great, it's committed. And this is a snapshot. So remember when we said that Git is used to track changes? It won't always be looking for changes and remember the changes you've made. You have to tell it that I want you to save this change and remember this change. It's almost like when I create version 1, version 2, and final version of my files. You can relate it to that. That's the same as committing a change. So we've just made our first commit. And if we go back to Git and we refresh, you won't see anything here, because in this diagram, you'll see that we've just done git add and git commit. It's still in local. So it's still on my own computer. It hasn't reached remote yet. So that's the next step. If I want to share my code, share my changes, I will need to git push them to this remote repository here. So to recap, the changes do exist on my local. So if I open up this file right here, you can see the changes. So that's why it's reflected in the local. But it has not yet been git pushed to the remote or uploaded to remote. So nothing shows up here. And we'll change that in a second. So the next step is to git push. And what we want to do is, you can do it two ways. So in that same window, you can hit the push button right here, or you can do that right here. So both of these green buttons do the same thing. And you'll note that before we hit git push, it says your branch is ahead of origin main by 1 commit. That means that you have 1 commit stored in your local. So stored right here in your computer, and you haven't pushed it yet. So we're going to push it. And essentially pushing it is like uploading it to GitHub or to the cloud. And now if we go back to GitHub, you'll see that, yay, my code is now in the remote repository. And if this was anything more meaningful than these random comments, and I wanted to share it with people, I can just copy this link, share it in the chat, and you would all be able to see it. So that's one way you can collaborate with code, is that if you upload things or push things to GitHub, you can directly link people to your code. A handy function for this is, let's say this is hundreds of lines long, and I wanted Jasmine to take a look at specifically lines 3 to 5. Now I can select them just by clicking on it. And if I wanted to select multiple lines, I'll hold down Shift, and then it'll select everything in between. And you'll see that the URL changes. So if I send this link out now, and someone else clicks on it, they'll see that there are the highlighted lines. So they'll know what to focus on. So that's a handy function in GitHub if you ever want to share your code. You can also copy lines, things like that. All right. So now that we've learned how to create our first repository, remote repository, then clone it, so kind of download it into local onto our own computers. We've made changes to our first file, uploaded those changes or pushed them to the repository. Now we'll talk about branches, because if we want, oh, Yuka.
Before we go on to branches, can I ask a quick question about like committing and pushing?
Go for it, yeah.
So how often do you commit the changes that you've made versus like how often do you push them up online? Or like when would you do that? Like what are some like increments that you use?
So I'll use a work example. So if we're coding for work, usually I would commit my changes whenever I make a meaningful change. So let's say I finished a chunk in an app, or I finished a feature in a model, or a significant part of my analysis, and I want to remember it. Basically, anytime I would create a backup for my work, that's when I would commit a change. For pushing it, it really depends. I could push it right away, and I usually do push it right away. There are people who wait until the end of their workday to push, but I usually commit and then push right away. So I see those two as kind of part of one action of saving my changes whenever I want to create a backup. In terms of cadence, though, so it's almost like asking people, how often do you save your work? Some people will hit save Control-S many, many times on the same file just to be safe. And then there are people who like to live life on the edge, and they save maybe once a week. So it's really up to you. What do you think is worth saving? But just note that committing and pushing is essentially creating a snapshot or a backup file of your work. Yeah, but Yuka, how often do you commit and push? I'm curious.
I'm a very commit happy person. So whenever I I guess I'll commit minor changes as well, even if it's not a big substantial change, just so that I can track it and be able to go back at any increments of my change. But pushing is something, because a lot of my projects I work on alone, so I don't really see a need to push too frequently, but I can see that being useful, with pushing more frequently being useful if I'm collaborating. So pushing not as often, but committing very often. It's just a matter of being able to take as many snapshots as I can.
Yeah, and so that's a good example of how like a solo contributor works versus if you collaborate with people, pushing is more important. So like Yuka mentioned, pushing is that step of uploading your stuff to the cloud or to GitHub. And the main purpose of that is to be able to share. But if we're working on projects alone, we really don't need to push or share as often. So it really depends on what your project is about. But thanks for sharing, Yuka.
That's really answered. Thanks.
Oh, Shannon, do you want to show people kind of like I think you had an example kind of Git history that you were showing earlier, that you want to show people like how many changes are in kind of a commit or between commits that you have for a certain file, and that might help visualizing on like what size of your commits can be, or something like that.
Sure. Let's see. It can be something small. This code might not make too much sense because it's actually Python and I'm cheating.
Just look for the red and green.
Yeah, but like Jasmine mentioned, it actually this. I'll go down to another file. It's actually up here. You'll see that changes were committed for 4 files up here. And they're detailed right here, what files they are. If we go down somewhere, you can see here, significant changes have been made right here, where I think there was some analysis that was done here. And we felt like, okay, this is time to save the outputs of that analysis. We've also created some functions and deleted some functions. So you'll see in the red, this is where things were deleted, and then things were added in the green. If you see gray or white here, that means no change happened. So to give an idea of what one commit contains, yeah, this is when we didn't need this function anymore, so we deleted it, but added new features in a new function. You can also view commits right here. So if you go to any repository, you'll see the number of commits here. You can click on it. And then here it says created a page in an app. Click in that, and you'll see what changes have been made here. So these are one of the features for collaboration. So if I wasn't the one who made this commit, I was a partner who did it on a project, and I wanted to leave a comment. I can do that. I can also comment on a specific line if there are questions, concerns, whatnot. And this just facilitates collaboration so that I don't have to keep sending over questions to Jasmine, for example, asking like, hey, what did you do on line 2? And then linking her what line 2 is. We can do it all on GitHub right here. So any questions about what we've done so far? Creating a repo, cloning it, doing our first commit, and our first push. Any questions so far? If not, we'll move on to creating a branch. And to remind everyone what branches are for, it's for collaboration purposes mostly, but also if we work on our own project and we want to do some development work or some changes, and we want to test it out on the side. An example of that, or a metaphor for that, would be if I had my project on display or a report on display, but then I wanted to make some changes on the side, and I wasn't ready for the whole world to see these changes yet. I would do it on a scrap piece of paper on the side, do some designing, testing, and then put these changes into this main project or main report. That is essentially the concept here, where we're branching off to the side so that we don't affect the main project that's beautiful and working already. We can do our own testing, development on the side, not worry about breaking things. And then once those changes are solid, then we can combine our changes back. So branches, again, are these new lines out here. And you'll see that you can make branches of branches, but we won't worry about that too much right now. Git can get a lot more complex and depending on your needs, but for now, we'll create a branch off of the main branch. So to do that in RStudio, we will go back to RStudio to our top right corner or wherever your Git tab is located. And then you'll see these two purple boxes and this white diamond, and you'll click on it. You'll see that it brings up a window called New Branch. And this is where you want to name your new branch. So going along with the example of me building a Shiny app, I want to create a new page, let's say, a documentation page on my Shiny app. So I would call it something meaningful, like documentation page. And I want to do it off of, I would keep these settings the same. And then click create here. You'll see that it says switch to a new branch. And what that means is, if I maximize it, you'll see that before it said main right up here. And that meant that I was on the main branch, or this branch right here. So that kind of presentation-worthy version of my project. But the moment I created a new branch, it helped me switch to that branch. So now I'm on a parallel version of it. I've just copied what's happening in the main branch, and now I can go and make my changes, go have fun with it without worrying about breaking my actual project. So this is the action of creating a new branch. So to reiterate, we click this purple box, give it a name, and then click create. And so once we've done that, if we go onto GitHub, click refresh, you'll see that there's also a new branch right here. So right now the contents are the same because I created a copy, but let's make a change and upload it to and update our branch. So let's say I'm creating a documentation page. So I've written some code to create this page, and it's done now. I'm happy with it. Now I want to create a snapshot of my changes or save my changes. You'll note here that for my script, it no longer has a question mark because I've already told it that, hey, I want to keep an eye on this file, but it has an M, and M stands for modified. And it's telling me that, hey, this file that you told me you want to keep your eyes on, you've made changes to it. And so I can git add and tell Git that, hey, I'm ready to save changes, and I select this file. Commit. I'll write a meaningful message. So created documentation page or app. I'm happy with the code changes I've made, commit it. So that's saving locally. So now these changes appear on my computer, but they're not yet available online yet. To make it available online, I'll git push. And if we open up GitHub right here, go to that branch, the documentation page branch, you'll see that there are changes here. So my new code update is right here. But if we look at the main branch and compare it side by side, you'll see that these changes aren't reflected. So again, if we go to our documentation page or documentation branch and compare it with our main branch, you'll see that my changes have been updated in the documentation branch, but it does not affect my beautiful and working app that I want to show the world. Because these might be changes that I'm not ready to show yet, or it's still work in progress. So that's the difference between updating the documentation page branch versus the main branch. In some projects, you'll hear that the main branch is protected. And what that means is you can't push to the main branch. So you can't make any changes to the main branch. The only way you can update code in the main branch is to create another branch. And then we'll go next into pull request. So I've made my changes to the documentation page. I'm happy with it. Good to go, tested, it looks beautiful. Now, if I go to the main page, you might see a pop-up here that says compare and pull request. So you can click that. If you don't see it, you can go to pull requests right here. And this is where you can create pull requests. And that's the action of merging your changes back to the main branch. So I'm happy with the changes I've made. Now I want to merge or combine the two versions together. So I'll click compare and pull request. And you'll see that I want to compare the documentation page with the main. And it's important to note the order in which these branches exist. Do you want to combine changes to the main branch? So it's kind of like your foundation and you're adding your new changes on, or is your foundation the documentation page? So usually base would be main because that's kind of your foundation. And then any changes you've made will be on a separate branch, and that's your compare branch. Usually we would leave some meaningful comments again for future us. So some meaningful comments here. To describe what just happened, why am I creating this pull request, what big changes have I made? And once I'm happy with this, I can create a pull request. Now GitHub will check, is there anything weird with the actions you've just made? So are there conflicts? Maybe someone else changed the piece of code that I changed, but we won't get into that. So GitHub okayed my pull request. It looked at the two branches and said, yep, you can combine your changes. And now I'm going to click merge pull request and confirm. So what I've just done is I've combined my changes back to this main branch. Now my changes are on that main project or that main branch, and they're essentially copies of each other again, the two branches. So if I don't plan to do any further work on it, I can delete the branch. But if I want to keep it there, I'll just go back to my repository. Note that I'm on main, but you'll see the new code right here because I've just merged or combined the changes back. So what we've just done is we've made a change, or we've created a separate branch. So we've copied the main code, and then we've made a change on the code on the side. We've tested it, we're good, we're happy with it. And then we've combined those changes back to that main branch or that main project. So that is how you can update the main branch or any code on the main branch. Any questions there? Awesome. So that brings us to the end of. Oh,
there's a question that just came in from Alexis, and they ask, how does pull requests relate to the git pull command shown on the local / remote commit / pull diagram you showed earlier?
Hi, yeah, that one. Sorry. Hi, this is me who just asked. Yeah, is that a different sort of pull, or are we just using pull in two different contexts to mean two different things? It's a little confusing, just that we're calling two things pulls, I guess.
Yeah, for sure. It is confusing because we're using the word pull to mean two separate things.
Okay.
You're right in that they don't, there's no relation. We're just using the same word. But you can understand git pull as like downloading changes. So that's different from a pull request. We can call them PRs so we're not using the same word, but PRs basically combine changes between two branches. Yeah.
So it's just sort of an unfortunate fact that the same word can be used in the two different contexts. It's just
essentially, yes.
Okay.
Yeah.
All right. Okay. All right. Confusing, but that makes more sense now. Thank you.
Yeah, great question. So to reiterate, a pull request or a PR is what we just went through, where we made changes on a separate branch, and now we want to combine the changes on those two branches. And if you're a visual learner, that's where these nodes intersect, come back. So that's when we merge a PR, a pull request. To git pull, an example of that is, let's say Jasmine wants to come in now and kind of download the changes that I've made. She will need to go and make a pull request. And I'll make an example of that right now. Let's say I've updated some code here. Pretend I'm another person. Okay, so someone else, a collaborator I'm working on the project with, has made some change. They've git committed, or they've done git add, git commit, and git push. And now I can see these changes on the remote. But you'll note that it doesn't show up on my local. And that's because if we go back to the diagram here, if we go back to the diagram here, the changes exist in the remote, but we have yet to git pull. So what I want to do to download those changes is I'll click this down button right here, and that represents git pull. So, oh, sorry, I'll have to go to the main branch because I made this change on the main branch. Click Git pull, and you'll see that it's telling me, hey, one file was changed. There were 8 lines that were added. So 8 insertions or 8 lines were added. It will say, I believe, deletions or something to that effect if lines were removed or deleted. And then you'll see that, wow, these changes are now reflected. So lines 12 to 17, lines 12 to 17 were added. So that's part of the Git pull portion. Hopefully that illustrates the differences between a PR and Git pull. Git pull is kind of like downloading changes. PRs are to merge changes. Any other questions? If not, I'll hand it back to Jasmine. But if any changes, or sorry, if any questions do come up, feel free to reach out. There's contact information, I believe, on multiple platforms and also on the workshop website. So yeah, hopefully this was useful for everyone.
Thanks, Shannon. I'll give you a virtual applause for the great workshop that you gave. Unfortunately, we can't have everybody unmute at the same time, but thanks again. Definitely super helpful introduction to Git and GitHub. I hope everybody tries it with either like a personal project or if you're able to at work and start tracking your changes there. And the only way to get better at GitHub is to get in GitHub is to like keep using it. And even though like sometimes like there's a lot more to learn beyond what we saw today, but if you just like start integrating it into your kind of workflow, then you'll only get better at it. Even if it means that you're only just Git pull, pushing, committing, just getting that kind of muscle memory in is really important. So thanks again, Shannon, for coming today. Thank you, everybody, for taking some time out of your Thursday evenings. You can, and Shannon will be sticking around for a bit. So if you have any questions about the content today or anything about Our Ladies or anything, feel free to stick around. Yeah, and we'll see you at the next Our Ladies meeting.